Hello, my friends. Welcome to Thermal Engineering Concept and Principle. How can we determine the dimensions of geothermal vertical heat exchangers? This is the objective of the present episode. Come with me and let us go deeply in this subject with Professor Ali Tarad. Hello, everybody, and welcome again. This is Professor Ali Tarad. I will introduce in the present episode some information or useful information about the modeling of the borehole in heat pump applications, and uh, we will pass through the use of equivalent diameter technique. And now I'm going to introduce the eccentric position of the equivalent geometry inside the borehole. Thank you for your support, and let us succeed in our mission to transfer knowledge for the person who needs it. The objectives of the present video are mainly uh, based on the introduction of equivalent diameter and how can we implement it in the prediction of thermal design of the single tube heat exchanger, and how can we position the equivalent tube in the borehole. In the previous episode, we passed through model number one, and today we will introduce model number two, and this model has also been published by me, and then we will take a case study on how to use it and compare it with other correlations available in the open literature, and then we will arrive to the closure of the content of the present video. Borehole depth estimation and the length of the heat exchanger. In the present episode, we will illustrate a new correlation and model for prediction of the heat exchanger length. Let us assume that we have a single U-tube in a well surrounded by grout, and to present a geothermal heat exchanger. We want to get a general form to predict its length. We will transfer this U-tube to a single equivalent tube with a diameter d sub e. The first assumption depends on considering that the volume of the grout material is fixed for both geometries, which leads a final form for the equivalent diameter to have the value square root of d naught, as shown in equation number 1. The second step in this model, I will transfer this equivalent diameter to a position in the borehole where we are keeping the offset distance and the shoulder between the external surface of this tube and the borehole diameter fixed. That is corresponding to a value equal to U naught, Y naught. And Y naught, as presented in equation 2, if we used it to present the value of L sub PE, which represents the distance between the center of the equivalent tube and the center of the borehole, can be obtained in the form L sub PE equal to half times d sub b minus 2 u naught minus the equivalent, which is represented by equation number 3. And we will use the same equation which we have presented in other or previous correlations and episodes, that the thermal resistance of the grout material can be represented by the offset resistance for a tube or cylinder inside an external cylinder for the shape which is representing the equivalent diameter. You may find all the details about this correlation in the reference shown at the bottom of this slide, and usually it will be the first reference in the list, which I am going to include in the description box of the present episode on the YouTube channel. To investigate the present correlation, let us consider an example where we have a heat pump is used to cool down a space by using a geothermal heat exchanger as a condenser, and it has the cooling load of 3.5 kilowatt, where it can be used to produce cold water as 7 degrees Celsius, and then it can be passed through a fine coil where a maximum temperature difference can be obtained for the water to be 5 degrees centigrade. The evaporation and condensation temperatures are as shown in this expression, that for evaporation temperature is minus 10 degrees Celsius and a pressure of 5.72, and then the condensing temperature and the pressure were 30 degrees centigrade and 18.76 bar respectively. Of course, these values representing the operating conditions for the refrigerant, which is R410A, circulated in this heat pump. The rejected load was estimated to be around 4.4 kilowatt, with a COP of this heat pump to be 3.57 for cooling. And the condensation heat transfer has been used as a typical value for this refrigerant to be 3000 watt per meter degree centigrade. The upper or the tube itself is composed of a single tube made of copper, and the table shows two different geometries to be examined in the present episode. Of course, we have to use a thermal conductivity for the grout material, which we have selected even in previous episodes when we have examined the other correlations to be in the range between 0.73 to 1.9 watt per meter Kelvin. Results comparison between the present episode correlation and the others, which have been uh, expressed in different and published in different journals for me and for others, uh, can be presented in this part. We have B equivalent, which has been expressed as the square root of D naught, and it has been calculated and included in this table. The uh, variation of the group specific thermal resistance uh, and its variation with the thermal conductivity can be shown in this figure for the geometry G1. And it's clear that all the behavior of all of these correlations have the same trend. We have the maximum value is around 0.35, where the thermal conductivity of a grout was 0.73, and it has been predicted by Tarad star, and this is a previous correlation, and the minimum was predicted by Raymond. It was around 0.25 meter Kelvin per watt, and the minimum value was obtained when the thermal conductivity is around 1.9, which is the highest thermal conductivity in our examination, and it was around uh, a value which is less than 0.25, 0.15 for Tarad star, and it was less than that, around zero point 0.1 for Raymond. This is for geometry G1. And for geometry G2, we have the higher value was predicted by both Etal and the minimum value by Raymond. It seems that Raymond correlation usually has the lower value among others for the thermal resistance, and all other correlations have predicted values in between and occupying the zone between the maximum and minimum values. The total resistance has been calculated for both geometries. And of course, these values should be used to predict the um, depth and the length of the heat exchanger, which can be used to achieve a certain cooling load, which represents the condensation load for the refrigerant Freon 410A, which can be mainly depends on the total heat transfer rate and the temperature difference between the fluid and the soil which surrounds the borehole. To estimate the borehole depth of the heat exchanger, geothermal heat exchanger, which can be deduced, of course, from the length of the heat exchanger. Uh, it depends on the D equivalent, which has been calculated for both the geometries, and these values were used to estimate the grout thermal resistance and the total thermal resistance. These values were used to estimate the depth or the length of the heat exchanger for different values of temperature difference between the condensate and the soil. For this part, we have used a temperature difference of 20 degrees Celsius for geometry G2, and we have also examined the heat exchanger length where a temperature difference was 15 degrees Celsius. Of course, that increasing the temperature difference between the condensate and the soil will produce lower depth and lower heat exchanger length. And in this example, we have found that the highest length for a specific value of temperature difference was obtained by uh, both etal and the lowest was predicted by Raymond. Of course, these values mainly depend on the temperature difference and the total resistance, which has been calculated throughout this episode. And in that effect, we have to mention that the orientation of the single tube in the heat exchanger has no effect, in fact, because we are only dealing with one single U-tube, and this can be vertical or horizontal. So, in general, the length of the heat exchanger is higher for the lower temperature difference of between the soil and the condensate. Of course, more details can be obtained from our reference of the present correlation as shown in the list of references seated in the description box of the present episode. Dear friends and colleagues, we arrive to the final part of this episode, that is the closure. We passed through the modeling process of geothermal heat exchanger, which is described for the vertical borehole, and we used the equivalent diameter technique in the sizing and specifying the dimensions of the geothermal heat exchanger. Then we applied a case study for the application of the models described in this episode. We have some useful references. You may find them at the bottom of this video in the description box. And thank you for listening. And at the same time, I urge you to subscribe and share what we have in the YouTube channel with your friends to achieve the main goals of creation of this channel, and see you in the near future. Bye bye.